Decarbonization is a phenomenon in steel where as the steel gets forged and heat treated, the outer layer of carbon in the steel diffuses out. This can cause problems with...
Decarbonization.
Oh, you mean the topic wasn't decarbonization? Well, then what was it? The steel industry is responsible for approximately 7% of the global carbon emissions. But what can be done to reduce these emissions? While there are multiple simple options like ceasing the production of iron from iron ore or changing steel so that it no longer uses carbon, neither of these options are viable since more iron is needed to support a growing society than can be produced by recycling, and the definition of steel is quite literally iron alloyed with carbon. So if we can't stop the use of carbon in its entirety, what can we do to reduce the use of carbon? Using hydrogen instead of carbon in the refinement of iron would create a byproduct of water instead of carbon dioxide. This would reduce emissions significantly, but the technology is still under development. Pilot-scale trials have shown that it is possible, but there is still more work that needs to be done to see what effect this type of iron production has on later production stages. Another method of reducing carbon emissions is improving the efficiency of steel production. Luckily, the recent AI boom has created many new possibilities for improving processes and efficiency. But AI models need data for them to work, and a great way to collect that data already exists. It's a technology everyone knows and loves. It's responsible for the video you're watching right now. That's right, it's fiber optics. Well, modified version of fiber optics. They use a Bragg rating to measure various types of data. With these fibers, it is possible to measure stress, strain, or temperature along a section of the fiber. This method of measuring can be used to collect data at a higher resolution than was previously possible, which then allows for the development of stronger models that can more accurately detect problems and increase production speed. There are limits to what the fibers can accomplish, as above certain temperatures, the fiber will begin to melt. There are materials that can withstand more intense environments, but those are significantly more expensive than a normal fiber optic cable. With these technologies and a multitude of others, it is possible to help reduce the carbon footprint of the steel industry and possibly even go carbon neutral.